So the first periodic property in the chapter number 7, which we are going to study, is effective nuclear charge. What is the meaning of effective nuclear charge? So many properties depend on the attraction between the valence electron and the nucleus. So you can see this is a picture which is shown for the sodium element, and sodium in the center red dot is shown as a nucleus which have 11 protons, and outside this light blue cloud is for the electrons, and it has 11 electrons. So the electronic configuration will be like this: 1s2, 2s2, 2p6 and 3s1. So the last electron, which is the 3s1, is called as a valence electron, and this 3 cell is called, the third number of shell is called the valence shell. So the every electron have an attraction from this nucleus, but as we will move further from the center, the core electrons, which are the 10 electron, they work as a shield. They repel this electron away from this nucleus. That is why the total effective nucleus attraction become less compared to other inner electrons, and that charge, effective nuclear charge, meaning the effective nuclear attraction which is occur on the valence electron due to repulsion of the inner core electrons. So electrons are both attracted to the nucleus and repelled by the electrons, and the force of an electron experience based on both factors, that is called the effective nuclear charge. And this effective nuclear charge is represented by ZEF. So effective nuclear charge, Z effective, is found this way: Z effective is equal to Z minus S, where Z is atomic number and S is a screening constant, usually close to the number of inner electrons. And effective nuclear charge is a periodic property. It increases across the period and it increases slightly down the group. What does it means? It means that effective nuclear charge increases, you can see this is the periodic table, and effective nuclear charge increases according across the period. So as we will move from left to right, which is the period, because atomic number increases and number of protons and number of electron increases from left to right, that is why effective nuclear charge also increases and slightly increases from top to bottom also. So effective nuclear charge increases from left to right in the period and from top to bottom also. And this picture, this graph is shown the trend, how the effective nuclear charge is increasing, and some point it decreases but it again increases. So a little bit more about the effective nuclear charge. The positive charge experienced by the outer shell electron is always less than full nuclear charge experienced by the inner shell's electron, partially offset a positive charge of the nucleus. So this is the formula, and you can consider like if a nucleus have 3 cells, just like in case of sodium, and last electron is 3s1 and inner 2 electrons will be 1s2, and then in this middle one there will be 2s2 and 2p6. So most of the electrons are in the middle one, and if they are not there, so the positive attraction was experienced from this from the nucleus by this electron is a lot greater than the valence electron. Valence electron, which is the last electron on the outermost shell, or the electrons which are in the outermost shell or valence shell, they experience less positive charge attraction from the nucleus because of these screening electrons, and that is called the effective nuclear charge. So once again the same formula, which is a effective nuclear charge. Z is proton in the nucleus, and screening constant represent the portion of the nuclear charge that is screened from the valence electron by the other electron in an atom. And this is the size of an atom. This is the second property of atom. So the non-bonding atomic radius or van der Waals radius is half of the shortest distance separating two nuclei during a collision of an atom. So what does it mean? A non-bonding radius. So the bonding atomic radius or covalent radius is the half of the distance between the nuclei in a bond. So this picture shows, you can see the nuclei cannot get any closer to the each other due to repulsion between core electron on the neighboring atom. So this picture shows that there are two atoms are coming together. Let's consider this two hydrogen atoms are there. So hydrogen has one proton and one electron. Another hydrogen also have one proton and one electron. So these two atoms, usually hydrogen is a diatomic gas, it's written like O2. So the distance between the two nuclei is called the bonding atomic radius. So the bonding atomic radius, which is the distance, half of the distance between the two nucleus, and non-bonding atomic radius is the distance from the nucleus to the outermost shell, and electron distribution in the molecules, and this blue cloud shows the electrons are distributed in this one. So the non-bonding atomic radius, which is this one, is or van der Waals is the half of the shortest distance separating two nuclei during the collision of an atom, and bonding atomic of radius or covalent radius is the half of the distance between the nuclei of a bond. So basically this picture is showing that how we determine the size of an atom, which is based on the distance between the either bonding electron or non-bonding electrons. So size of an atom in the periodic table. This figure shows the trend of in the bonding atomic radius. Bonding atomic radius means bonding atomic radius, which is this one. The half of the distance from between the two nucleus is called the bonding atomic radius. So this radius is used to define the size of an atom, and the bonding atomic radius tend to decreases from left to right across the period and increases from top to bottom of a group. So atomic radius decreases from left to right. So when we move from left to right in the period, the atomic radius decreases. The size of an atom also decreases and increases from top to bottom. So the size of an atom increases from top to bottom. So this is the trend of the size of an atom in the periodic table. So we can also summarize this through this table, that atomic radius within each group, the atomic radius trend to increase from top to bottom. Atomic radius trend to increase from top to bottom, and within each period the atomic radius increases moving right to left, and if you will move left to right, it will decreases. So this was about the effective nuclear charge and the size of an atom. We will discuss about the size of an ions in the next video.